Now let's talk about the esp-4. What I already recognize is the different mounting position. Can you describe me why?
We have here on our demonstration board already realized the 10 degrees inclination. You remember in the theoretical part that we are able to measure much faster than with the dBK+4. We have to mirror away the sound parts, and therefore with the 10 degrees inclination, the wet material runs parallel to the plate here, so that the sound parts can be mirrored away from receiver and transmitter.
Okay. What can you tell me about the pin assignment for the esp-4?
The pin assignment is similar like the dBK. We have a 7-wire cable, 2 wires for power supply. We have one output for label detect or splice detect. We have another output for wet break. We have 3 input lines. With one input line, we can perform the teach-in. The second input line is to switch on an automatic guidance to follow any kind of changes in the material. Yeah? And with the third, you have the option for synchronization.
Okay. I have a label here. Can you show us how it works and how we have to teach in?
Yeah. We have the ESP set up in label mode and quick teach. Therefore, it's really very easily. I put the label inside the barrier. I choose here, my box is only to give different signals on the control input line. I give high level on input line C1. This enables the teach-in procedure. And I take the signal back, and the teach-in is already finished. Okay. And you can see it here. I get a red LED indicator for the label, and inside the gap, it changed to green. This indicates only backing material, and therefore, now I can detect the leading edge of every label.
Is it also possible to use link control software to visualize
in the same way like we have seen it for the dBK+4. Okay. You loop in the communication channel to our link control adapter and via the USB cable to the PC.
And do we have different housings and mounting possibilities for the ESP?
We have 2 housings. We have the standard housing. It looks like the standard dBK+4 means receiver and electronic in one thread, and below the transmitter. Here we have built up the sample with M12 housing. This transducer are smaller than the M18 transducer, and they are in the frequency higher. So this is 500 kilohertz ultrasonic frequency, and this is 400 kilohertz ultrasonic frequency. For label, we usually use the 500 kilohertz ultrasonic frequency. For splice detection, we use normally the 400 kilohertz ultrasonic frequency. Then the esp-4 looks like the dBK+4.
So with the same muster as we have seen in the theoretical part.
I have to read out the settings of the sensor. I will do it here now. And after reading out the parameter, I can go to the measurement writer. I push the button here, and now, as you can see, you see the labels and the gaps of the label. It's the same characteristic you have seen in the theoretical part of the presentation.
Okay. So can a label sensor then also detect a double sheet?
No. The labels must always be glued onto the tape here, onto the backing material. If the labels would not be glued, then the fork sensor would reject any teach-in process. The red LED indicator would flash and say, failed teach-in procedure.
I have understood label sensors and its applications. Let's remind us of the difference between a label sensor and a splice sensor.
Label sensor and splice sensor have a lot in common. You can say the internal hardware structure is identical. We have different software strategies. Therefore, an ESP comes as a label sensor and a splice sensor. You choose which function you want to use. The same for the esp-4. You can use it as label sensor and splice sensor. You can say a splice is a single label on an endless backing material. Yeah? You need different strategies to find the splice. And the splice is the most difficult application.
And if we compare multiple labels on a backing material to a single splice on a web material, you could say that a splice is actually just a single label on a very long web material.
Yeah.
Is this the reason why you have put a label and splice sensor in one housing?
That's the reason. Yeah. The biggest difference is when you have a label sensor, the label sensor sees all the time both levels that he has to detect. The label sensor is able to detect the signal level for the label and the signal level for the backing material, and he can follow the change of the signal all the time. A splice sensor sees most of the time only just the signal level of the web. And this can be for ultrasonic signal very, very inhomogeneous. And then suddenly the signal change comes from an unknown splice. And the basic signal of the basic material can already be very noisy. And therefore it's much more difficult to detect a splice compared to detecting labels on a backing material.
Why is it more difficult to detect a splice? Has the paper web material special features?
I would not say feature, I would say characteristic. So also very good papers can have, for the ultrasonic signal, a very noisy signal result.
So how do you solve it?
With special software algorithm, we can see for a long time the paper material, we learn the characteristic, and the splice has a slight different characteristic to this, and intelligent software algorithms are able to find these parts in the data stream.
Okay. So can you show us how to teach in the splice sensor?
Do you have a splice?
Well, Frau Hake, do we have a splice?
Johannes, look what I have for you here. It looks like a splice.
It is a splice, yeah.
So can you show us how to teach in?
I knew that you will ask this. Therefore, I had in the meantime changed the setting for the esp-4 from Quick Teach for label to Quick Teach to splice. So okay. I'm well prepared. We put the web inside the barrier, and now I have to initiate the teach in. And I do this that I give on input line C1 high level. I enable the teach in procedure. The flash starts, the LED starts flashing. I move around about half a meter of the material, then I stop the teach in procedure, it's finished. And the green LED indicator shows me the web material, and have a look. I see the splice is coming, I get a red LED.
Okay.
And that's very easy as to teach in Quick Teach label. You give high level on C1, you transport around about half a meter of the material, you stop teach in, and then you can detect the splice.